All right, so we are going to start chapter 7 today. We're going to take chapter 7 pretty slow. So we only have a couple weeks of school until the end of the semester. We're going to get about halfway through chapter 7. Like I said, we're going to take it pretty slow. And then we'll come back when we come back second semester and go back over some of these things. So chapter 7 is all about exponents. And actually, before we get started, I am super guilty of this incorrectly using some vocabulary here in math. So what I should actually be saying is it's all about powers. So whenever we talk about an exponent, I think oftentimes we think of this whole thing x to the n as the exponent when in fact the only thing that's the actual exponent is the little number. Okay, so what we call the exponent, this entire thing, is actually called a power. So we have our exponent, which is the little number. The big number is going to be called the base, and then all together is going to be a power, and then the little number is going to be the exponent. So I'm going to try to do a better job at using the correct vocabulary. So we're going to talk about two types of powers, two types of exponents today. We're going to talk about zero exponents and negative exponents. So to start off, the zero exponent, this is the easiest, simplest exponent ever because anything to the zero power, any number to the zero power equals 1, which I know seems very confusing, and we'll learn in later sections why this is true, but I'm telling you, 2 to the 0 power is 1, negative 5 to the 0 power is 1, 3.72 to the 0 power, it's 1. So let's get that out of the way. That's super easy. Now, the one that's going to be more of the focus today is a negative exponent. So a negative exponent, if a power has a negative exponent, it is not considered simplest form. So anytime you circle and box your answer, if you have an exponent that is negative, you are not done. You need to fix the negative exponent. And this is really easy to do. So to make a negative exponent positive, okay, you're going to flip the power over the fraction bar. And remember, this word power, that's the whole thing, okay? So watch what happens here. We have this power, a to the negative n. So that negative, that right there, that's the problem. So to make the negative n a positive n, you're going to take this entire power, the a, the n, everything, and you're going to flip it over the fraction bar, which means it's going to move to the denominator. When you do that, the only thing that happens is this negative n becomes a positive n. Nothing else changes. So for example, if I were to go the opposite way, if I have 1 over a to the negative n, I see that negative exponent, cannot have a negative exponent. So when I see that I have a power that has a negative exponent, you're going to take that power, take that base, flip it over the fraction bar. The a stays the same, but the negative n then becomes a positive n. So these, I think up front should be pretty simple. So if I have 3 to the negative second, what we're not looking at negative numbers, we're looking at negative exponents. So if you have 3 to the negative second, what you're going to do is you're going to take that power, you're going to take that base, so the base is the 3, you're going to move the base to the other side of the fraction bar. So the 3 stays the 3, but it just moves to the denominator. When you move that power to the fraction bar, that negative 2 becomes a positive 2. And then if you have nothing in your numerator, you'll just go ahead and put a 1 there. And we wouldn't want to leave it as 1 over 3 squared because 3 squared is 3 times 3. We would want to call it 1 over 9. Now, here's where these get tricky is you just have to be really careful about knowing what the exponent is being applied to. So the exponent is only being applied to the base that's right underneath it, unless there's parentheses. So when you have 2x to the negative third, this negative third is only applying to the x. So when notice that you have your negative exponent, you're only going to move the base that has the negative exponent. So that 2 is actually going to stay in the numerator because the 2 doesn't have a negative exponent. The x does. So the x moves to the denominator and the negative 3 becomes a positive 3. Then this last one, 1 over 4 to the negative second. The 4 has a negative exponent. Now the 4 is in the denominator, so we want to move it up to the numerator. Now you're going to move the base, which is the 4. The 4 stays a 4, but the negative 2 becomes a positive 2. And we wouldn't want to leave it as a 4 squared because 4 squared is 4 times 4, which gives me 16. Okay, so this is a new chapter. So we are going to want to make sure we set up our table of contents. The next open page in your interactive notebook should be page 65. So on page 65, we're going to do your chapter 7 table of contents, which means we'll leave page 66 blank. So page 67 is going to be your next open page, which is where we will glue in 7.1, which is 0 and negative exponents. So make sure you get your table of contents set up. We're going to want to get this graphic organizer glued into page 67, and then we'll flip on over to page 68 and look at some examples. So remember that anytime you have a negative exponent, your answer is not in simplest form. So that's kind of the big thing we're looking for today. So number 1, let's say we have 4 squared. Okay, well this is easy. There's no negative exponent. It's just 4 squared. And 4 squared just means 4 times 4, which is going to be 16. Okay, number 2. Number 2 says 4 to the negative second. Okay, now here's where we have this problem because we can't have a negative second. So what I like to do, as you guys know, I'm a big visual person. So as soon as I see a negative exponent, what I like to do is I like to circle powers that have a negative exponent. So that 4 for me is going to get circled. What that tells me is that I need to move that power. So that 4, that base, is going to move to the other side of the fraction bar. So that 4 moves down to the denominator. When I move that 4 down to the denominator, the negative 2 becomes a positive 2. And then remember, if you don't have anything left in your numerator, you want to write a 1 in there. So you have 1 over 4 squared, which is going to be 1 over 16. Okay, number 3, let's switch it up a little bit. Let's do 2 to the negative 4th. Now, once again, I like doing the circling thing. So I see 2 to the negative 4th. I see a base that has a negative exponent. So I'm going to circle the 2 to the negative 4th, which tells me the 2 needs to move. The 2 needs to be flipped down to the numerator, which means the 4 becomes positive. So it's going to be 1 over 2 to the 4th. Remember, 2 to the 4th means 2 times 2 times 2 times 2. 2 multiplied by itself 4 times, which is going to be 1 over 16. Okay, let's make them a little more difficult here. What if I take that same problem, but I put parentheses and I call it a negative 2 to the negative 4th? Now this is where you need to be really careful because if you remember, I said that the exponent only applies to the base that's directly underneath it. Now, if there's parentheses, it includes everything that's inside the parentheses. So in this case, this is taking negative 2 to the negative 4th power. We'll see in the next one how it's going to be a little different. So what that means is whenever I'm moving my base, I need to move the negative 2. Now the 2 stays negative, but remember when I move that power to the denominator, it's going to flip that negative 4 to a positive 4. So the parentheses are really important here because this is going to take negative 2 to the 4th power, which is negative 2 times negative 2 times negative 2 times negative 2, and 4 negatives are going to make a positive. So that's going to be 1 over 16. It's going to be positive. Where if for number 5, if I take the same problem, but if I don't have the parentheses, it may look like the same problem, but what changes here is since I don't have the parentheses, this is not including that negative sign. I'm only taking 2 to the negative 4th power. So technically, when you flip your power, just the 2 should go down. The negative should stay up in the numerator with the 1. So I have a 2 to the positive 4th in the denominator. So this is going to be the same thing, except it's going to be a negative 1 over 16. And then number 6, what if I have in parentheses negative 2 to the 0 power? Now, if you remember, I said anything to the 0 power these are the easiest ones ever because anything to the 0 power is 1. Now you do need to pay attention and make sure the negative is inside the parentheses, so it is going to be a positive 1 because anything to the 0 power is just 1. Okay, so let's move on to some variables. I think the variables tend to be a little bit easier than the numbers. So number 7 says 3xy to the negative second. So remember, what I like to do is I like to look for negative exponents, and I see that negative 2. Now I'm going to circle the base that the negative 2 belongs to. Now if you remember, the exponent only applies to the power to the base that's directly underneath it. So the only thing that has a negative exponent here is the y. So what happens here is the 3x, they stay. We're not going to move them. But the y had a negative exponent. So I'm going to move the y to the denominator, and the negative 2 becomes a positive 2. It's going to look something like that. Okay, number 8 says 3 over xy to the negative third. Remember, what we're looking for are the negative exponents. And once again, the negative exponent only applies to the base that's right underneath it. So the x is not included. So what happens here, if you didn't circle the 3, it means you're not going to move it. If you didn't circle the x, it means you're not going to move it. But I did circle the y. So the y is going to move from the denominator up to the numerator, and the negative 3 is going to become a positive 3. Okay, and then number 9, what if I have 3 to the negative second, y to the negative fourth over x squared? Now very carefully, we're going to circle everything that has a negative exponent. So I have 3 to the negative second, y to the negative fourth. Now in the denominator, it's an x squared. The 2 is positive, so I'm not going to move the x. The x squared is going to stay. But I circled the 3. So the 3 needs to move from the numerator down to the denominator. The negative 2 becomes a positive 2. And I circled the y, which means the y needs to move from the numerator down to the denominator. And the negative 4 becomes a positive 4. We're going to throw a 1 up there in the numerator. And then last thing, we wouldn't want to leave it as 3 squared. So we're going to call it 1 over 9 x squared y to the fourth. Okay, just a few more here. Okay, number 10. Number 10 says 5 squared x to the negative third, y to the negative second, z to the fourth. All right, so remember, we are looking for those negative exponents. So it's 5 squared. The 2 is positive. Not going to do anything with the 5. But I see x to the negative third, y to the negative second. So I didn't circle the 5. I didn't circle the z. I did circle the x and the y. So you're going to move those down to the denominator and change the power of their exponents. And we wouldn't want to leave it as 5 squared. 5 squared, 5 times 5 is 25. Z to the fourth over x cubed y squared. Okay, number 11. Number 11 in parentheses, negative 3 to the negative second, x to the 0 over 2 squared y to the negative fifth. All right, so remember, we're looking for negative exponents. So I see this negative 2 right here. Now, since there's parentheses underneath here, it means that the negative, since it's inside the parentheses, is included. In the denominator, I also see a y to the negative fifth. So what happens here? I circled the negative 3, so the negative 3 stays a negative 3, it just moves to the denominator, and that negative 2 becomes a positive 2. I did not circle the 2 in the denominator, so that 2 squared just stays down there. Now I did circle the y in the denominator, so that's going to move up to the numerator, and that negative 5 becomes a positive 5. And then that x to the 0, remember, anything to the 0 power is 1. Which means it's going to be y to the fifth times 1. Well, it's just going to be 1. So we're going to have a y to the fifth in the numerator. Now, negative 3 squared gives me 9. 2 squared gives me 4. So I have 9 times 4. So my answer is going to be y to the fifth over 36. Okay, and last one, number 12. Negative 10 to the negative second, x cubed y to the negative fourth, over 7 to the negative second, z to the negative fifth. All right, so we're looking for those negative exponents. Now notice the difference between 11 and 12. I have a negative 10 to the negative second, but this time there's no parentheses there, which means when I'm circling the 10, I'm not going to circle the negative. It's not included. I'm also going to circle the y, and I'm going to circle the 7, and I'm going to circle the z. So I didn't circle the x cubed, so we're going to leave the x cubed. I also didn't circle the negative, so we're going to leave the negative, but everything else needs to move. So the 10 goes to the denominator, the y goes to the denominator, the 7 goes to the numerator, and the z goes to the numerator. And remember, when you flip those, it's going to change all of those signs. So in the numerator, once again, there's no parentheses here, which means I'm only squaring the 7, so it's still going to be negative. It's going to be negative 7 times 7, which is negative 49. And then x cubed, z to the fifth, 10 squared gives me 100, y to the fourth.